As a part of our EEE 310 course, we are asked to implement time dimension multiplexing system, popularly known as TDM system. TDM is a modern way of sending two or more voice signals through a single channel. Although we have some limitations in our circuit design, the TDM system successfully works.
We used ICL 8038 to produce sine wave. Initially we designed Colpitt's and Windbridge oscillator, but they don't operate well at low frequency range 300 to 3400 Hz. So we opt for that IC. Besides, it offers opportunity for changing frequency range, which was not available with those designs. The 10K port connected between pin 8 and VCC plus 12 volt mainly controls the frequency.
First, we produce a 20% duty cycle clock 20 kHz with a 555. It was done by suitable choice of R and C. Then it is input to a clock of T flip-flop. However, 7476 is mainly a JK flip-flop with its J and K short-circuited to 1. Q and Q bar of T flip-flop is ANDed with the original clock to produce desired shifted clocks.
The major part of transmitting is sampling a sine wave with one of the shifted clocks. Firstly, it was thought to be done with MOSFET or BJT, but finally it was done with ADJ633 IC, which provides excellent job. End of the transmitter part, we have added the output of two ADJ633 ICs through registers of 1K, and luckily the transmitting part is over.
Main clock was sent to 7476 flip-flop IC. Q and Q bar of that IC is multiplied with original transmitted signal by AD633, so that two sampled signals are separated. Low pass filter, which is designed with 4 kHz cutoff frequency, perfectly filter these sampled signals to regenerate original sinusoidal signals.
At first, we try to generate sine wave using our sine wave generating circuit. Here we try to hold the sine wave in our oscilloscope to observe a decent sine wave. Now we can vary our sine wave frequency by varying the potentiometer of the circuit. Yes, here it is working. We can see that. This is the main clock of our system. We generate it by 555 timer. Now this is the output of our T flip-flop. This T flip-flop is needed for producing shifted clock. We'll see later. Here we see the Q and Q bar of the T flip-flop output. Here it is. Now our shifted clock is generated. We use it to sample our input signal. Now we can see the sample signal of our main sine wave. We do it by multiplying the main signals to the shifted clock for both cases. We use IC 8633 for multiplying purpose. Now we see the clock signals above and corresponding sample signal. If we reduce the time deviation of our oscilloscope, we can easily see that it looks like a sine wave. This is our 2 adder sample signal. We produce it by using our adder circuit. Here we clearly see that there are 2 signals existing. After transmitting the adder signal by transmission wire, we found it in our receiving side. Here it is our receiving side clock and it is our receiving side T flip-flop output. We multiply the adder signal to Q and Q bar of T flip-flop accordingly. Here we can see. Now this is the output after multiplying the signal. So after proper filtering, we have found that the receiving side signal is almost look like our input sine wave signals. So the TDM system successfully works. Thanks for watching this video.